buffers continued. So there are also what we call alternate methods to creating buffers. And so here's a really good example. So if I have a weak acid, and I said before, in order to create a buffer, you have to have a conjugate base of the weak acid. And so the conjugate base is usually behaves as a weak base. But here's a buffer where I'm adding a strong base, and it works because of the ratio of the weak acid to the strong base. So what I know when I react these together, what happens is that all of the zero point 0.2 moles of the NaOH react with zero point 0.2 of the HF. So there's 0.2 of the HF left over. Kind of look at it as an ice chart. And what happens is that the NaF goes up by the zero point 0.2. So now what I have in my solution is I have 0.2 moles of the weak acid, and I also have 0.2 moles left of this salt, sodium fluoride, that is a strong electrolyte that ionizes into sodium, and that's just a spectator ion. It's not going to do anything to the solution. And this. So I have 0.2 of this, the conjugate base, as well as the weak acid, because remember what happens, HF would in equilibrium turn into hydrogen ion and the fluoride ion. So all I need for my buffer is to have present some of this and some of this, which I would have if I mix these amounts together. So you can see here that I'm ignoring liters, and typically you can do that because the number of liters that the ions are in are equal, so that portion of your fraction would cancel out, so you don't really need to worry about it. So let's see if I had a weak base and a strong acid. So the same thing again, as long as I have more of the weak species than the strong, it would work. Because what's going to happen is that all of the HCl will get used up because half of the NH3 will react with all the HCl, leaving you with 0.3 of the weak base. And as all of that reacts, it's going to produce the conjugate acid of the weak base. So I would have in my reaction vessel both the weak base, and I would have its conjugate, which would just be the ammonium ion, because what would happen to that 0.3 moles of ammonium is that ammonium chloride is that it's an electrolyte, it's a solid that turns into ions, and so I would have the NH4 positive ion and just spectator chloride ions. So I'd have everything I need present in order to form the buffer. So here's a failed mixture. So looks like I have the same things as I have in my previous example, but now I have too much acid. What happens is that all of the acid reacts with all of the base. I have none of those left. I don't have any weak base left over. And now all I have is all ammonium chloride. So I would just have the conjugate acid. I wouldn't have the other half of the pair that I need. And so here's an example where you could look at what would happen if you added 0.4 moles of sodium cyanide to 0.2 moles of HCl, and it could be mole per liter, molar. same, it would be the same because they're in the same container, therefore in the same total volume. And so what would happen is that all of the acid would react, only half of the weak base would react, and I would have left over conjugate acid of the weak base. So there would be my conjugate acid, there would be my weak base. So that would be another example. Okay. Then let's look at what could you add to 0.4 moles of H3PO4 to give a buffer. Let's look at this little list and check things off. So to have this buffer, there's my weak acid, there's my conjugate base. I need to make sure that what I put in this weak acid has a conjugate base component to it. Here it is, sodium hydrogen phosphate ion is present, so yes, that would create a buffer. Here's another example where it's the alternate route to it. As long as I have less of the strong base reacting, that means all the hydroxide disappears, reacts with half of the weak acid to produce an amount of that conjugate base. And then here's an example similar to the one that I showed you before. So here's some other examples. Here's some possible combinations, some nice examples to look at.